Okay, as we begin chapter 17, let's take a look at fatty acids. Okay, and a brief overview of what is a fatty acid, since this chapter focuses on lipids. Okay, so fatty acids, we can characterize them as long carbon chains, typically 12 to 20 carbons in length. Okay, so we got long carbon chains that are unbranched. Okay. On the end of the chain, we have a carboxylic acid group. And fatty acids can be considered saturated or unsaturated. Remember, saturated would be if all of the carbon-to-carbon bonds are single bonds. Unsaturated is there's a double bond in that carbon chain between two of the carbons. Now, underneath unsaturated fatty acids, we can have mono-unsaturated, which means we just have one double bond. Okay, so it may be mono with just one double bond between the carbons. Okay. It could be poly unsaturated, which is considered like many, or more than one, so greater than one carbon to carbon double bond. Okay. Now, the other thing about unsaturated bonds or unsaturated fatty acids, the double bond that you see present in that chain can lead to a cis or a trans configuration. Remember that cis is when the double bond exists, and then the two priority groups coming off of that double bond are on the same side. Okay, or it could be that you have the trans configuration where the two priority groups are on opposing sides. Okay, so this can lead us to having different shapes, different arrangements. You've heard of the phrase trans fats, saturated fats, unsaturated fats. The cis and trans configuration inside of these unsaturated fats can lead to different properties, different outcomes. Okay, some of the common fatty acids you might be familiar with are like coconut oil. Okay, coconut oil consists of a 12 carbon long chain. Palm oil, okay, 16 carbon chain. Okay, or olive oil. Olive oil is 18 carbon chains. So some of the common so say food oils and nutrition you're familiar with, like butter. Butter has got 16 carbon chain in it. Okay, now some of the properties that we see differences, saturated fatty acids, because of that all single bonds, so all carbon to carbon single bonds, these saturated fatty acids are typically solids at room temperature. Okay? Because with those long chains that are all single bonds between the carbons, they're able to stack like sheets of paper. Okay? They're able to stack up, really squeeze together, which allows them to solidify. Whereas the unsaturated fatty acids with these double bonds in there, whether it be one or many double bonds, puts a kink or a twist into the chain, doesn't allow them to stack together, to layer, so we see them to be softer, liquidy at room temperature. Okay, and that's all because of the dispersion forces. Those saturated fats being able to get really close together, really stacked, the dispersion forces between them increase, okay, seems to have a greater influence, whereas the unsaturated with that kink, twist in the chain doesn't allow for this great of dispersion forces.